So in our previous episodes, we worked through setting up agents to work with our code repository. In the last episode, episode 4 of this series, we took one agent to a GitHub issue, and it took that GitHub issue all the way through to a pull request. And that worked, and it was fine. So why would you need to have more than one agent? So here's the same setup. We have our pull request, and this time we're going to, we have our GitHub issue here. We want to allow an order to be canceled. And you can see here the summary of that, the customers and the support staff, they need to be able to cancel an order that hasn't been shipped yet. And if we jump over to our Claude agent here, you can see we've got our orders demo schema, and it's a single table with the orders on it. And it's a fairly simple, straightforward table. So what we want to do is do the same thing that we did before. So we want to do implement GitHub issue number 1. So this time, instead of a single agent working on the GitHub issue, we're going to have a series of agents. We're going to have an agent that plans, an agent that delegates, one that writes the domain code, one that writes our application code and handlers, one that writes tests, and one that does a full review of everything else that all the other agents have done and doesn't touch anything else at all. I'm Barrett with NimblePros, and this is the final of our agent AI series. So let's talk about agent teams. All right, so while that's working, let's go ahead and start talking about agent teams in general and the kinds of things that you can do with teams of agents that are specialized. So we're going to start with, kind of a review of the previous 4 episodes. So we had 4 previous episodes to this series. The first one we talked about our instructions files, our standards. Then we talked about skills and giving the agent the capability of doing more things in a uniform and repetitive fashion. Then we talked about MCP servers, where we could have our agents, have better reach, being able to reach out, touch our GitHub repository, touch our SQL Server instance, touch, other things like that. And all that was good. And we brought it all together in the 4th episode, but it's still a single agent, and that agent still has a problem. That agent is a generalist. Just as with, human developers, if you have one developer and that developer is a generalist, they do a pretty good job and they can get through things. But if you have a full team and each of them has their specialties, their specializations, their areas of focus, if you have a developer who is a front-end developer, a developer who's focused on databases, a developer who's focused on the back-end code, each of them contributes something a little different to the team. And they generally have more in-depth skills around their specific area of knowledge. And it's the same way with AI coding agents. You can have a generalist agent, and it does a lot of things pretty well, but it doesn't always do specific things very well. And if you can set up agents that are focused on specific things, they can do a better job at those specific items that you give them assignments to. And the reason for that is, there's actually a couple of reasons, but the biggest reason is context. An agent has a limited context window. It has only a certain amount of information that it can hold on to at a certain time. And that includes, the information that it knows about and the things that you're passing back and forth, the information about that. And the more information that agent has to hold on to, the more things it kind of has to shove to the side and not know about. But if you can have an agent that is specialized and it has a particular focus, they're able to keep their context focused on that area of knowledge and have a better in-depth view of that particular thing. Another piece is that, you can have conflicting concerns. If you have an agent that has to juggle all these different pieces, it has to switch back and forth. It has to shove aside its knowledge of the front end in order to do the back end stuff. It has to to shove aside its knowledge of databases to do, the front end stuff, whatever it might be. And so it can't hold on to that knowledge, again, coming back to the context window. It's unable to do certain pieces really well. And like all generalists, it knows a little bit about a lot of things, but a specialist would have a deeper knowledge of a specific area and could do a better job with that particular area. So that's generally what the problem is with having these generalist agents. So being able to create multiple agents and each one having its area of focus allows you to get a more in-depth knowledge, a better curated skills library. For instance, talking about skills and like MCP servers, if you have a bunch of different skills and you have a bunch of different MCPs, those things all get passed back and forth in the context. And if you create instead a specialized agent or a series of specialized agents that are all very narrow, that all have a very tight focus, you can curate the information that is passed along with that. You can give them only the skills files, only the MCP tools that they need to be relevant to their roles. And again, that shrinks the context of that particular agent. And that really matters a lot more than you might think. Again, these context windows are limited, and the more that you try to shove into each particular context, the more it costs you in tokens, and the less specialized and in-depth it can get. Because again, I keep coming back to it, those context windows are limited. So, if you have a domain agent, it doesn't need to know about databases. It doesn't need to know about user interface. If you have a data agent, it doesn't need to know about user interfaces. It doesn't need to know about the domain. It doesn't, beyond just the general scheme of the application. Not because it can't be trusted with that information, but because, a domain agent, persistence is not its job. A user interface, data is not its job. And by setting aside, these irrelevant pieces, you hide that noise and that extra information from its context, and it's able to focus more on the role that it's there to play. And that makes them all more consistent, and it makes them all more knowledgeable about their area of specialization. So let's talk about the structure of that. The examples, as with the previous videos, my examples are all from Claude, but they all generally work the same way. You just need to learn about the specific implementations for your particular AI coding agent and implement them on there. With Claude, you've got in the Claude folder, you've got a agents folder, subfolder. And in that subfolder, you have a series of folders. Each one is specific to the agent, that particular agent. For instance, in our example here on the screen, we've got an orchestrator agent, we've got a domain agent, we've got an application agent, a testing agent, and a review agent. And each one will have its own Claude instructions file. And each one will also have skills and MCP information that are specific to that particular agent in those subfolders as well. So for instance, on your domain agent, you don't need to give it, skills related to the application. You don't need to give it skills related to testing. And so each of those skills subfolders is specific to that particular agent. And each one of those specialist files, let's jump over here to the actual file themselves. Let's look at an example. So if we open up our agents folder here and say, for instance, we look at the application agent and not skills. There we go. So this particular one, it says, you are an application layer specialist. Your responsibility is, use case orchestration only. The commands, queries, the handlers, and all that particular information. The instruction file will also have a specific list of the things that the agent is responsible for, the what you own list. and what you do not own. So you are giving specific instructions on what they are not to touch. The kinds of things, you are not responsible for aggregates. You're not responsible for data entities. You're not responsible for business rules. The repository, you don't do testing. Don't run .NET test, and so on and so forth. You need to be specific in both the things that it is responsible for and the things that it's not responsible for. And that's very important to keeping that context limited. You also have, the conventions that you would do, and what you would include in here are the conventions that are specific to that particular agent, and nothing else. You don't include anything that is general, anything that is the responsibility of any of the other agents. And again, so you've got the skills, you've got the tools, those things that are specific to that particular agent. As always, you want it to include instructions on how to verify the success of the things that it implements. So build and verify. So in this particular case, you run .NET build when your work is complete. Make sure that it builds, fix any compiler errors, but do not run test. The testing agent owns that step. And the last thing that you need to make sure that you include for specialist agents is a handoff. You need to say, okay, when you're done, you need to report back what it was that you did and include in that any information that is needed for the next agent in the series. So if we go back here to the main instructions file here, you can see an example here of things that are general to the entire application. So things that would be needed by any of them. Your general architecture, your coding conventions, testing, things to never do, shared skills. And this information down here at the bottom, specifying what the team is. So this project uses a team of specialist agents. See the orchestrator information for the roster and the delegation rules and how to proceed from one to the next. So if we come back up here and look at the orchestrator, and we can see how it ties everything together. So for the orchestrator agent, it says you're the orchestrator, you plan, delegate, and validate, you do not implement. Again, telling it what it's responsible for, what it's not responsible for. Do not write any of these things yourself. If you find yourself writing code, stop, delegate. And then we give it instructions on what agents are available to it. So it says, okay, you have a domain agent. Here's the things that it's responsible for. Here's what you do to hand off. Here's what you are to expect back from that agent, and so on and so forth. It does that for each of these agents. It says, okay, for each of these steps, this is what you do. And then the delegation rules. And this is one of the key pieces here. This is giving instructions on the order of the delegation. So it says you start with domain. Then when you get the results back from that, you go to application. Then you go to test, and then you go to review. So, and it's, if there are agents that you can have running in parallel, that's fine. You can give it instructions on that. Otherwise, you need to give it specific instructions on when each agent is to be called. So it says, don't invoke an application until a domain is handed off. Don't call test until application is handed off. Don't call the review agent until until the test agent is completed and both .NET Build and .NET Test are successful. If if any of your agents report a failure, stop and report. Don't try to fix it. Don't try to do anything else. And never let two agents work the same files at the same time. So again, giving it those specific instructions that that help to keep everything in flow and in line. And if this, this particular agent, again, we've got these tools and so on and so forth. And the workflows. We talked about workflows in the last video. And if you haven't watched the previous videos, I encourage you to go do that before you go much further here. But we talked about workflows in the last video and how, give us the step-by-step, here's what you do to implement things. Especially we looked at feature implementation in the last one. That was one of the example that we used. And here's, the step-by-step that you go through. Well, here we're doing the same thing. We're just expanding it to use teams of agents instead of a single agent to do that workflow. To do that workflow. All right, so let's go back to our slides for a moment. So again, I talked about, I walked through the example here of you need to be specific in the things that it owns and the things that it doesn't own. That's very important so that a specialist agent doesn't overstep its boundaries. You need to make sure that it understands this is what you're responsible for. This is what you're not responsible for. So don't go outside your lane. Stay in your lane. And the handoff. We talked about, this is the glue that kind of keeps everything together. When you're done, summarize, report back to the orchestrator. Tell the orchestrator the information that it needs to pass on to the next agent. So again, what was created, what was changed, give file by file summary, any domain decisions that you made, in this particular one for the domain agent, and what the next agent needs to do. Those are the instructions, to give it back. Talked about the orchestrator, the steps that it goes through here. I showed you that example and what it needs to do to coordinate the activities of all the other agents and to keep them all in line and moving and flowing. The order, the order matters. As I mentioned, if there are agents that can work in parallel, that's great. You can set it up that way. Generally, you want each agent to complete the work that it's doing before it passes off to the next agent, because the work that the domain does, is required for the application agent to be able to go forward. And, the domain and the application agents both need to complete their work before the tests can be done. Unless, if you were doing test-driven development, you would reverse the order. You put test agent first, say, okay, you need to create the tests before, we start with writing the code. And then have it, circle back and say, okay, now iterate through that until, things are successful, until everything builds and tests successfully. So, if you're doing test-driven development, the structure would need to be a little bit different in how it coordinates things. And you might have to do, multiple iterations to loop through and make sure that everything works. And then, of course, review can't be done until everything else is completed. Once all the code is written, have that agent do the review, check and make sure everything builds and passes, look for bugs, look for that kind of stuff, and then report back, but don't try to fix it yourself. Let the orchestrator circle it back to, if there's a bug or a failure in the domain agent, have the orchestrator circle back and make the domain agent fix that. Again, because you're specializing on that, the review agent doesn't really understand necessarily everything that was done by the other agents. It doesn't have that same depth of knowledge because the review agent is a generalist, essentially. It's just looking at this overall view and saying, okay, does everything look right? Is there anything, any glaring issues standing out? If there is, circle back to the agent that's responsible for that and have them fix it. And then, we put in that instruction, if anything completely falls apart, stop and tell the user and get instructions. And the orchestrator is important. The orchestrator is responsible for that reporting back. So that, the biggest thing to remember is that you need to have that orchestrator who coordinates things. It takes on the role, essentially, for instance, if you have a large team of developers, generally what you're going to have is that team lead or maybe project manager who's responsible for coordinating the activities of everyone else does. And especially if you have a large team, the team lead is not really doing a whole lot of coding themselves. They're spending all of their time working with the various members of the team, getting them, keeping them on track, getting them to do the right tasks, coordinating that passing off of information from developer to developer, and making sure everything comes together into a cohesive whole at the end. And that's really what you want to do with these agent teams is the same process. You want to have a coordinator who puts everything together, who coordinates things, who keeps everything on track, and is able to pass that information from specialist to specialist. And that's really the whole thing together, trying to accomplish the same task. Now, teams agents are not the end-all be-all. It's not the answer to every problem, because there is a cost to using them. It does require a lot more setup. It does require a lot more effort, and it can overall take up more of your tokens. Working with the AI. So there can be a cost to that, but there are advantages to doing it, and if you're using it in the right situations, it is an advantage. So when is a team worth it? When is a team of agents worth it? If you're doing a large piece, a large development task, where you've got a huge feature that you're implementing and it has a lot of pieces to it, and of course, then you got to do the testing and whatnot. That's a good time when an agent team might be a good piece to put together and to use for your application development process. If you're using, and anytime that you're doing really a massive engineering effort, that's really a good time to implement these agent teams. If you're doing a simple task, if you're doing a proof of concept, if you're doing a focused development piece on something, so maybe you're just doing some development or some database work, or maybe you're just doing some UI fixes. That's time when agent teams are overkill, and you really don't need to implement them there. You need to understand, really when it makes sense and when it doesn't make sense to do it. So a few do's and don'ts, for making sure that your agent teams are successful. Again, make sure that you have those explicit boundaries and handoff points. Make sure you're detailing out what the handoff is, what the expectation is of, you do this piece and here's the information that you need to give me back so that I can coordinate with the next AI agent. Have those predictable, as it says, handoff outputs. Need to make sure that anything which is specific to a particular agent goes in that file. That agent's instructions file and skills files. Anything which is shared information, things that will be needed across a bunch of different agents, that's the stuff that you put in your top level file. Again, you don't want to do any duplication. You want to make sure that you're going through and looking at the instructions that are given to each of the agents and at the top level to make sure that you're not duplicating your effort there, because that can lead to confusion, and it can also lead to less efficient agents. And also start small. As with everything that we've been talking about, start with the minimum that you need to do in order to carry out a particular piece. Maybe you want to start with two agents. One that does the focused development, and one that does like a final review kind of task. Or maybe 3 agents. Add a testing agent to that. One to create and write the unit tests and integration tests and whatnot. So start with the minimum and work your way up from there. And then as you find pieces that need a bit more enhancement and a bit more focus, then you can split off, the agents and add another agent and create its focus. Maybe you start with a coding agent and a testing agent and a review agent. And then you find as you're going through there, well, okay, maybe I need somebody that's focused on our database side. So you create a database agent, and then maybe you need one that's focused more on user interface. And so you add a user interface agent and so on and so forth. So make sure that as you're working through there, start with the smallest that you need in order to have a team going. And then you can break it out and expand on that as you work through, and you figure out what works and what doesn't work, and where you might need some better focus on a particular agent. As far as the things that don't do, again, make sure that you are keeping each agent focused on its particular area of responsibility. Don't let the domain agent work on the testing files. Don't let the reviewer do anything as far as code, writing code. It should only be reviewing and reporting back. Don't duplicate your conventions across the instructions files. Make sure that each one has a specific area of focus and sticks with that focus. So let's get back here to our agent and just see what the result was. Let's actually jump back over to our files here and look at them for just a moment longer while that works. Okay, here we go. So, I mentioned I've got my application agent, my domain agent, my orchestrator, review agent, test agent. We kind of looked at, the orchestrator and the application agent. For instance, the domain agent here, if we look at here, you can see it's pretty much the same as the application one. It's just, a different set of responsibilities, a little bit different skills. For instance, skills, if we look at the application agent, he's got this add use case skill. A domain agent has a domain behavior and a value object skill. So you can see that the skills, are specific to that particular agent. If we look at the review agent, you can see you're the code review specialist. Never fix anything. You never approve anything. You are there to review the work that was done by the other agents and then give a response back, a summary back. You look at the diffs and the changed files. You report on whether there's any risk, any convention violations, whatnot. Here's a checklist of things that you go through. So, for instance, make sure in the architecture section, make sure that there's nothing in the domain layer that shouldn't be there. Make sure that we're giving the right results back. Make sure that we're using the correct structure for value objects, and so on and so forth. And then, as with everything, give that response back. And here's how to hand off to the next one. Same thing with the test agent here. So I've got a skill for writing unit tests, handler tests, and this your testing specialist, and so on and so forth. So you can see the structure of these files is pretty much the same from one to the other. You've got the instructions on what you own, what you don't own, what the role is, what your conventions are, what your expectations are, any skills that you need, any MCP tools that you need would all be listed under here, and how to verify your work and how to hand off. So they all work pretty much the same way. So let's check back on our agent results here. All right, so you can see that it has completed all the work. It has implemented the code on a branch. There's 0 warnings, 0 errors. There are 18 tests created and passed. Actually, it looks like it added 5 more tests to what was already in place. And you can see the files that it created here, and so on and so forth. So all the acceptance criteria are met, and it gives information about things that it did not change, which is important. So you need to make sure that you're reviewing the results that come back from those agents and from the orchestrator. The orchestrator will gather all the handoff and results back, and will summarize all that for you before it reports back to you. Again, it says nothing is committed, nothing is pushed. It just created the pull request. And if I were to go back out to my GitHub page, okay, now you can see that we have a draft pull request. And you can see it adds order cancellation and cancel behavior, and so on and so forth. It gives specific details on what was implemented, how it verified things, and the various agent contributions. So you can see all the work here that was done creating the pull request, and it summarizes it in quite a bit of detail here. And in fact, it's far more detail than any of the rest of us would write as far as the pull request goes. But that can be good. And you can see that there were 14 files that were changed. Okay, so as we get in here, we've got our cancel order command and our handler, and the order canceled event, and the reason, and so on and so forth. So you can see all the various updates that were made and are ready for review. So it's gone through the agent review, and of course now, being a human, needs to do the human review. And if I will approve all this, then I would sign off of that, and then go ahead and turn this into a full pull request and merge it in. So in summary, we've gone through 5 episodes now, and ways to improve your AI agents. Each of those episodes had its area of focus. In the first one, we talked about instructions files and how to keep your AI agent aligned to your standards. Then we talked about skills files and how you can enhance that agent with playbooks and how to carry out multi-step tasks. Then we looked at MCP servers and giving our agents ways to reach out to other tools, for instance, GitHub, internet libraries, looking at your SQL Server instance or database instances, and so on and so forth. In the 4th episode, we looked at workflows and how to put all that together to describe an outcome and not the individual steps, and being able to give the agent the capability of going through a complex process from beginning to end all on its own. And now in this episode, we've talked about agent teams, taking it to that extra level where each of those agents is specialized and has its area of focus and it's able to keep its context focused and is able to provide more effective and consistent results because of that specialization. So that's a full journey of how you take AI from just auto-completing code all the way up to putting together teams of orchestrated agents to specialize and to work together to carry out complex development tasks. Each of those layers stands on the layer before it. And most of the value is really, in the first couple of things, those instructions and those skills. But everything else just kind of adds on to that and is able to build on the basis of the first two. So that's it for the series. And again, as with all the other ones, there's a companion blog post out on our blog. I encourage you to go out and check those out. And if you haven't watched the other 4 videos of the series, make sure you jump back and take a look at each of those. So thank you for watching, and have a good day. Now go build something.